All right. All right, we'll get started. Okay, good morning, everyone. Thank you so much for taking the Saturday and joining us. And we would like to quickly talk about what Technogize is, what we do, and also how are we different from the other consulting organizations. And today we have presenters GP, Gaurav Pasarkar, GP we call him, and then we have Soham, who's going to talk about the session which you have come for. Then to talk about Technogize, we are an IT service and a consulting firm. We do custom-based software solutioning to the clients. So how we do, we use the latest technologies which are available in the market to provide solutions. We identify ourselves as problem solvers rather than switching to any tool or domain for that matter. So why are we different from other consulting organizations? Because the solution which we ship is robust, scalable, and easily maintainable. We do all of these things with the good engineering practices, and that's why we are a preferred consulting organization to our clients. To talk about our culture, we are an open culture organization, and to echo that, we have agile we follow, and we follow in a very pragmatic fashion. It's just not about something which is written in the book. We do follow. We ensure that we follow it so that it can solve the actual problem. To talk about we did talk about the technology, and to not only technology is, though it is on our core, we also ensure that we have values, because we are a people-centric organization, not just by theory. We ensure that we give the best of experiences to our people who work with us, who work with us, and also who engage with us. So values is something which we is a core, and what we call it as ABCs of values. What that means is always do the right thing, and when nobody is watching it, ensuring that you're always doing the right thing, and also all is one for all. That talks about the teamwork. We are always humble, be humble and kind. Talks about the humility and respect and empathy. Though we excel in whatever we do, we ensure that we stay to humble and to the ground. We also are taking ownership. That also talks about our responsibility, being responsible and accountable in whatever we do, and we ensure that transparency is flowing. That talks about commitment and being open. We create a difference. That talks about our thought leadership. So want to know more, you can also visit our website, and if you have any questions around things, you can always talk to the presenters today. Yeah. With that saying, again, we thank you all for coming in. That definitely talks about the passion which you have, because you're spending a Saturday and taking time. That's definitely not an easy thing. We've circulated the feedback form, so you can actually fill the feedback during the session or after the session. We keep sending this to you folks. Whenever you have any questions or something like that, you can always reach out to us. Okay, with that, I leave it to Soham and GP.
Cool. Let's get started. Sharing my screen. Just a second. Cool. Everyone able to see my screen, right?
Yep.
Cool. So let's get started. So what we are going to talk today is about front-end architecture and different NFRs and functional requirements that you need to take into account before deciding your front-end architecture. So our goal for today is we would be talking about different named architectural styles that are there in practice and which people are implementing from last 10-15 years, and even few modern techniques that are used to deliver front-end application. And at the end of the session, our goal is that everyone who has attended the session all different front-end architecture that are available in the front-end landscape, and because of which you could, because after the session you'll be aware of them, you'll be able to take better decisions based on the knowledge that you will gain in the session and the requirement that you will have in the future requirement that whenever you want to build a front-end architecture, you could refer back to this knowledge and take better decisions. The topics that we are going to talk about today is, we'll start off with discussing functional and non-functional aspects of front-end architecture. We will have a brief discussion about different non-functional requirements that you need to consider before coming up with a front-end architecture. Then we'll move on to discussing different architecture patterns. We'll start off with server-side rendering, then we'll talk about single page application, then we'll see what isomorphic applications are, then we'll discuss more advanced and latest front-end architecture styles. Those are Jamstack and micro front-ends, and then we'll have question and Q&A and breakout and networking post that. Good. So this is about us. So I am Soham. I am a polyglot developer. I try to be full stack, but I find myself mostly working on front end and JavaScript related things. I've been working predominantly on JavaScript, mean stack, mon stack things for a very long time now. That's about me. Gaurav, would you like to introduce yourself?
Cool. So I started my career as a pure backend dev. I spent a lot of time working with distributed systems. Later, I have slowly migrated towards front-end stacks to actually figure out how things actually work. So initially, my assumptions were that with front-end, it is only CSS and HTML, and that was not very, very interesting. I did not have a good understanding as to what front-end engineering is all about. It is only when I actually started exploring different front-end stacks, that is when I've gained that experience. I also work as a full-time DevOps for certain projects. So over a period of time, I have turned to a polyglot side, wherein I try to help the teams in whichever functions I can. Yeah, that's it for me.
Cool. So let's start with the session. Let's start with a quick discussion on functional and non-functional requirements. So what are the functional and non-functional requirements that you will analyze before choosing a front-end project? So this is a question to everyone. So anyone who wants to answer this can unmute and answer this or share their experience on different functional and non-functional requirements that they consider before starting a front-end project. Non-functional requirements would be requirements that are not like building a feature or which are not really related to the implementation, but it is more related to how your application would shape up and different components that you would have in your application at high level.
Even the choices of frameworks that you would choose. So for example, if you are using React.js for an implementation, what made you actually choose that particular library? Or if it is AngularJS, why AngularJS? If it is some other language or framework that you would want to use, what were your thoughts for choosing them? That is what we want to understand.
Well, Sam, I think for a few of the non-functional requirements, I guess the faster loading, I guess more in front end, you have the pages and the JavaScript libraries loading. So I guess what we would actually need is for them to load faster. I guess React provides you a faster way to do it. I'm not too completely sure as I've not worked on it, but I guess that is one of the main non-functional requirements, when for a front end, I guess, because as soon as it loads on a user screen, I think that's what we want for a good user experience.
Performance is what you're saying.
Yeah, correct. Yeah.
Cool, cool. That is one critical non-functional requirement. That is, the page should load as fast as possible.
Some of the non-functional requirements might depend on functional requirements as well. So what exactly, what kind of communication are we expecting through this web application? So suppose there is something which needs constant update of values, then we might use some different technology and etc. So yeah, so we might need to list down the functional requirements as well to
Cool.
decide. Yeah.
Makes sense. So the user behavior, how the user interacts with the application and how real-time information is displayed in the application, how dynamic it is, will also influence the kind of the architecture decisions that will make. Makes sense.
Correct. So something like a stock based application where you actually want to display what are the current NAVs of different stocks and mutual funds. That might have that might influence the type of front-end architectural style or the type of frameworks and libraries that you use as in comparison to something like a blogging website.
Yeah.
Any other non-functional requirement that anyone is able to think of?
So these comes in broader categories like performance, globalization, availability, other would be accessibility. I think these are the non-functional requirements by we should consider when for front-end architecture.
Cool.
By globalization, you mean localizing the same content in different languages like Espanol or Chinese?
Yes,
Is that
yes.
different? Okay.
I would prefer like what kind of application that we're going to develop, like the enterprise level application or like the basic level application. So first I will collect that information, and based on that, I'll finalize the framework. So like AngularJS itself designed for enterprise level application, and React it's quite fast compared to Angular. But the thing is like what kind of like there is a time frame also that we are bounded to deliver the project, so that we need to consider. If you are using AngularJS, you will have all the functionality because it's complete library. And if you are working with the React, you need to make sure about like what kind of framework that you are going to use at the time of development.
So community
Okay.
support and learning curve of a technology, time to delivery, how
Yes.
easy or
yes.
difficult it is to use a particular technology and deliver things.
Yes, correct. All those factors that you need to consider while developing.
Anything else that anyone can think of before we dive into each of them one by one?
Yeah, I feel like the type of content we are going to use for the particular framework. So, for example, if we use React is like a single threaded, and like if we use something other like Angular or something other like that, then we can't do heavy processing like image processing and video processing. I don't think so. That will be a good thing to do in React. So, so depending upon the kind of the requirements, kind of the work we need to do, we should choose the particular frame stack.
The use, so it will be your use case and use case of what you need to do. So again, image processing would be a very backend thing, but yes, I mean it is driven by front end, so you could consider that as well. Cool. Let's move on to few of the non-functional requirements that we have noted down and which are important to consider before we decide on an architecture pattern. So one thing which most of us didn't talk about is SEO. So search engine optimization is one of a major non-functional requirement that we should consider. especially if the application is client facing. If it is not an enterprise application, if it is an application like, let's say, Facebook, Netflix, that we as customers we are using, SEO is an important part, because a good SEO score means that your site is ranked higher, and every time you search Google for, I mean, if you search for shoes, Adidas and Nike should come up, and you will find that Adidas, Nike, and all the famous brands come up when you search for Google. So if you are starting a business in, let's say, shoe industry or apparel industry, so you want your site link to come in the first page of Google search, so that it improves your business, that increases your business, and increases your visibility as well. So search engine optimization is must have for B2C applications, where you are creating applications for a wider audience and not for a particular group. Enterprise applications where you don't want your application to come up in Google. So for those kind of application, SEO is not a must-have. But again, I'm just reiterating, for customer-facing applications, search engine optimization is one of a must-have and a very critical NFR that you should consider before choosing an architecture pattern. One thing which most of us talked about is the performance. Performance as in how fast the site loads. This, again, for public-facing application where the application is released to a wider audience with people staying in different demography, people with different internet connections and different kind of user expectations. The site load performance is very critical. So if the site is not loading within seconds, the user might get irritated and not even explore your site. So a must-have NFR is performance is one of the must-have things in your application. In performance, Web Vitals score is very important, and that is a good Web Vitals score is an indicator of good first-time load. So LCP, largest contentful paint, first input delay, cumulative layout shift. These are all Web Vitals, and a good Web Vitals score means that your site is loading faster and it is showing a relevant content in a very good time. So largest contentful paint is the time required for loading the most relevant content that is there on the screen. First input delay means how quickly the user is able to interact with your site. So if you have a text box or a button, a good FID score means that the user is able to input something into that text box or click the button and get the response from that button click as fast as possible. So having a good interactivity score is, again, I mean, a must-have if you are considering performance. And cumulative layout shift means is your layout jumping. If you're loading a page progressively, do you have layout shifts in your website? So a layout shift is again irritating for the end user, and having a bad layout shift score means your user is getting irritated with the layout shift that you're having in the user, and there is a chance that the user might not even explore your site further because he's irritated because of the layout shifts. So again, all in all, having a good first time load and having everything loading fast is very critical for applications which are again B2C. Another must-have non-functional requirement which you should consider is security. You don't want your site to be hacked, or you don't want any malicious user injecting things in your application. So these are all common attacks that happen in a web application. Cross-site scripting, DOS attack, it would be a user picking your API link or just getting access of your link and making millions of calls in a second to break your server. So you don't want these attacks to happen to your server. These are all very common security threats, and there are proven solutions for it. But before releasing your solution, security is one thing which you should keep in mind, and you should do an audit of your application for these common attacks before releasing your application. Next is platform support. One thing that you should consider before coming up with an architecture pattern is the different platform on which you want to release your website, web application, whatever you want to call it. So do you want it to be responsive? Are your users going to use it on mobile? What are the different browsers that you need to support? For enterprise application, in my experience, it is a deal breaker that your application should work on Internet Explorer, because most of the users are having Internet Explorer installed on their machines, and the enterprises block installation of any other browser for some reason. But then again, considering the browsers on which your application should run on is also a critical non-functional requirement that you should consider, and that affects your development timeline and development efforts as well. So browsers have different implementation for few of the features. So if you were to if the application working on Internet Explorer is like a deal breaker, you need to test your application on that. And if there are any specific specific handling or specific events that you want to do, which is very specific to IE, you would eventually have to work on that. So that is one of the things that you should consider about. And again, in the modern world, we have smart TV, smart watches, smart refrigerator. If you're working on an application which should also work on this device, you should also consider this as a non-functional requirement before choosing your library, your framework, and the deployment environment as well. The next critical NFR to consider is the development experience. Development experience is how fast a team is able to deliver an idea, is able to convert an idea into a running application. So how complex it is or how easy it is your development experience. If it is complex, your development experience is not good. If it is easy, the development experience is good. So having a good development experience is a win-win situation for both. So if a good development experience means it is easy to develop a mockup, and any mockup and design that comes to you, because you have a good development experience, you are able to convert a design into a working application quickly. So it means that the time to market is small. You are able to release it quickly. At the same time, the devs are also happy because they don't have to do a lot of core level stuff because of the community support that we have. So this just to give a crude example, every one of us would be using Axios or Fetch to make an Ajax call. So if that libraries were not there, you would have to call HTTP XHR request and write all the low level code just to make an Ajax call. So writing that low level code would mean you would have to invest a couple of days or even a week to get that right. But because there are libraries like Fetch and Axios available, you could just import them and just worry about the API call, the URL and the headers that you have to pass. So having a good community and framework support is a major factor in having a good development experience. Then learning curve of the framework and the language that you're choosing. So if you have to build a front-end application, how easy it is to learn maybe React.js or AngularJS, depending on the team size, also dictates your development experience. So how easy can a fresher pick up React.js or AngularJS and start delivering is also a critical factor that you should consider before choosing any framework. So in short, you should see how difficult it is to learn that particular framework or a language which you will choose to implement, and also see the kind of resources that you have who would be working on that. Development time is
so a lot depends upon the team composition as well. So if you have a mature team support who has actually spent a lot of time in building front-end applications, there could be different choices for front-end architectural styles and frameworks as in comparison to a team that has just been formed. So a lot depends upon the as Swam rightly said, the type of resources or the type of people that you're working with, not resources.
Yep. Again, the development time. So if you want to deliver an application as fast as possible. Am I audible?
You're breaking a little bit.
Is it clear now?
Yeah, but your video is stuck now.
Yeah, so development time is again another non-functional requirement. Can someone say hi to me? I'm not.
Hello.
Okay,
Hi.
okay.
You dropped.
No worries. I can present while this back. Give me a sec. Let me know. Let me know once it's coming. I can let you know. This is coming through.
Yes.
So was talking about the learning curve and development time. So development time is attributed towards again, it is again very similar to your team composition. If you have a mature enough team, how easy it is for you for the people to actually churn up multiple features. Things about maintainability. The maintainability aspect is also very important. Now, some frameworks and libraries they are very fast to get jump started with, but the moment the code base grows, the moment you start adding more features, it actually becomes very difficult to maintain and manage. So again, these decisions are again left to the team compositions. Things like deployment cycle, managing secrets, managing environment variables. These things are again attributed towards the type of team cohesion, team composition that you have. The last but not the least, the NFR is the infrastructure that is required to support your web application. Now, some applications are relatively straightforward. They require minimum infrastructure support, but there can be some complex use cases wherein you're actually rendering videos or high quality images, things like that. So, for example, if you're building a replica of Netflix, there are tons of resources that you have to manage. So your web application is actually churning a lot of content as well. So the infrastructure requirements required to support that type of application will be completely different to something like a blogging application or a CMS, wherein the content is relatively static. So that is also a factor you should be considering before committing to an architectural style.
Any questions on this? Anything that you want to share about what we just discussed or add on to what we just talked about?
Does it all make sense so far?
So one thing I would like to add is while considering a development cycle, 12-factor principles does help. 12-factor apps.
Correct. But that is how you manage your code. So how you manage your code, that is how you manage your secrets, that is how you manage your configuration. So yes, it is not just related to front end style of coding, it is also related to any programming that will relate.
Yeah.
So any application that you would want to manage, the guiding principles would be 12-factor.
In the first slide, we mentioned about vitals. So interactivity. So yeah, the first input delay.
Correct.
Will the accessibility be also part of this? Like, so suppose someone is handicapped or someone colorblind. So
yeah, some people could be
accessibility.
using screen readers. Yeah, absolutely. So it depends upon what you want your application. So what type of who are the consumers of your application? So if if you are actually targeting your application to a blind audience or people who would be using a lot of screen readers, then definitely these also make sense. So how easy it is for those people to navigate through your website, how easy it is to navigate through different content. So all of this is again part of your Web Vitals course as well. I don't think accessibility is something that Web Vitals consider by default out of the box, but I think there are projects like Google Lighthouse who would also try and explore how your application is accessible for different type of users.
Okay.
I think so. We can move on.
Yes, yes, okay. So let's start off discussing the architecture patterns that are are there. So if we go back 10, 15, 12, 15 years ago, so the only way or the one way which was getting used to deliver front-end application was server-side rendering. If you take example, simple examples of Ruby on Rails or PHP, or even ASP.NET or Java, your front end, your HTML was getting generated on the back end, and it was pre-generated with data, combining the data and the template that you have through a template engine, and that view was delivered to the browser. So a normal flow would be like whenever the user enters any URL, the request would go to the server, and on the server side, there would be some business logic or any logic to fetch the data, and you would have associated HTML templates for that particular route. And on the server side itself, the data and the template would be combined together using a template engine to form a view, and that view was delivered to the user. Now, this continued for a very long time. And one thing to notice here is you have basically three components in this architecture: your browser, your app server, and the database. And out of which, browser is not doing much of the work. It is just receiving a pre-rendered HTML template, and it is doing, the browser is doing the job that it does best, is just parse the HTML and paint the browser with whatever is there in the HTML and the CSS. Majority of the work used to happen on the server side, which did the job of data fetching, validation, whatever it is. Plus, it did the job of rendering the HTML, creating the HTML, creating the view, and then delivering it to the client. So if we go back 12, 15 years, the browsers were also not very efficient, and it made sense to do everything on the backend itself. So this was the architecture that was getting implemented for a very long time. This architecture had its pros and cons, but this was the way in which everything was happening. So with this architecture, let's evaluate the non-functional requirements that we just discussed about. So the first non-functional requirement that we discussed was SEO. So SEO is completely driven by a crawler. The crawler crawls the internet, and it accesses your different URLs, and based on the response that it receives from the URL, it indexes the pages. So the crawler expects a pre-rendered HTML to be there for it to extract information from it and then index the page. So with this architecture, with multi-page application or server-side render application, the page is getting rendered on the backend. It is creating a view which is HTML along with the data. So the crawler gets whatever it wants. It gets the content on the page, plus it also gets access of the head tag, in which you can embed some meta information for it to index. So SEO is very good for server-side rendered application. Infrastructure requirement. So because it is part of your server-side project itself, if you just consider front-end development, you don't have to worry a lot about how you are going to deploy it, because it is part of your backend project itself. You just have to write your code, and it will be served as part of your project. Performance is a mixed bag here. So any server-side rendered application. So one major drawback of server-side render application was it was not able to provide instant feedback to the user. So any change that the user wants, any request that the user makes, for example, when the user clicks on a button, the request goes to the server performs whatever logic it has to perform, renders the page, and sends the response back again. So it is a complete reload of the page every time the user makes any request. So the performance is not very good. If you have fast servers, it will perform very well, but as your scale grows, and if you have a lot of requests, you might see some delays, and in any which way, you would see some visual stitches in your application. So every time the user makes a call, I mean, makes any action, there is a call to the server, and the server enters the page and returns back the HTML. So you will see a small flicker every time the user makes any interaction with the application. But having said that, I mean, the first loads are pretty fast because the server returns a pre-rendered HTML, and the browser is very good at passing HTML and rendering things as fast as possible. So again, if you are looking at the overall user experience, there are some drawbacks of using server-side rendered application, wherein you see visible stitches, you see flickers, you see some delay on every user interaction because a call goes to the server every time the user does anything. Platforms, another NFR that we talked about is platforms to support. So it works. I mean, HTML, CSS works on most of the browsers. So platform to support. So there's no problem as such with platform, and it works well across platforms. Security wise, even though there are issues, even though there are attacks possible, but there are solutions for that available as well. So security wise, you are pretty good when it comes to SSR, and because everything is happening on the server side, you get that extra layer of security as well, because you're not doing much on the client side. You only have a cookie there in your browser to have some user context, but most of the things are happening on the backend itself. So security wise, SSR applications are good. Developer experience might vary. It varies from team to team. If you have good full stack devs, then the developer experience will be quite good. But if you have just front-end developers who are, I mean, specialized front-end developers with only front-end development knowledge, they might find it difficult to work with different server-side technologies because they are skilled only on HTML, CSS, or maybe JavaScript part. So there might be some learning curve for just front-end working on server-side development. Secrets, managing environment variables and secrets is pretty standard. I mean, it is the way you would do it for any API, the same way you can use it for your front-end side as well. Maintainability and team size, they go together. If you're working on a monolithic application, and if that application has grown in size, all the problems that come with a monolith would also be applicable to your front-end application as well, because you will have many people working on the same application with hundreds of pages getting developed. So maintaining the code, having same practices across the team, having same CSS practices, or reusing the same classes would get difficult as the team grows. So as the team grows, the development experience might reduce, because again, I mean, you might end up disturbing other pages. I mean, if you are overriding few styles, you might see some unexpected behavior, but these are common problems that comes with scale.
Plus, there are also, because the front-end pages are completely rendered at the server side itself, there is a high possibility that a lot of domain logic starts creeping into your presentational view. So for example, if you're building insurance broker application, right? You don't want your HTML pages or your presentation views to have that domain knowledge. So for example, there could be things like what are the surcharges for different rates. There could be things like how we would want to handle different insurance domains. Whatever this domain knowledge is, you don't want this domain knowledge on your front-end pages. You want this domain knowledge to be segregated inside your domain models. So because the entire code is developed and deployed as one packaged application, there is a higher possibility of this domain creep happening towards the presentational logic. And the moment the domain creep starts happening on the presentational logic, it becomes difficult to refactor, because if you want to refactor those HTML pages to something else by introducing a newer technology, you have to start thinking about what domain logic is going to change as well. So that's why the maintenance, maintaining a monolithic repo has its mix backup, has its own mix back.
Does this make sense? Anyone has anything to add on this? Any questions on this? On server-side applications? People could share their experiences as well if they have any experience of working on server-side rendered application. Cool. Let's move on to the next architecture pattern. So one major drawback that we saw with multi-page application was the overall user experience. So every time the user interacted with the application, to get the latest data, the application had to make a call to the server side, that then the server side would fetch data, render the page on the backend, and then deliver a pre-render HTML, which had a visible delay. You would always see some flicker in the application. And as time passed, a good rich user experience, immersive application wherein you have smooth transition between pages and you have real-time updates on the pages. So the requirement for these kind of application grew, and this led to developers adopting a new pattern called client-side rendering or single-page application. Release of AngularJS, the first one, Angular 1.x, actually gave a huge push to single-page applications. So this is a typical architecture of a single-page application. A single-page application is completely client-side rendered compared to what we just saw in server-side rendered. Rendering the page, the HTML that the browser rendered was pre-built on the backend and then sent to the browser. But the approach in client-side rendering or single-page application is completely different. The rendering of your application completely happens on the client side, and the server side is, there's a separation again between your, I'll just walk through the flow of the single page application. So when a user hits your URL and google.com or any of your application, the first thing that happens is the JavaScript and the static assets are fetched. So the static asset would be your index.html, your shell application that has calls to your JavaScripts, and the static assets would also be your JavaScript and the CSS. All of the static assets first gets downloaded in your browser, and then the browser starts executing a JavaScript. Once that JavaScript is executed, your code will have some API call, REST API call to fetch the data. So the browser will make the call to the REST API server to fetch the data. And again, on the browser side, the browser will again render the component once the data is fetched. So everything is happening on the client side, as opposed to the previous multi-page application architecture that we saw, where everything was happening on the server side. So this is one major difference that we can see in server-side rendering and client-side rendering. Client-side rendering, everything happens on the client side, and that is driven through your JavaScript. So the popular frameworks like AngularJS, React.js are helpful in this scenario where we have a lot of abstraction done by them, where we don't have to worry a lot about DOM manipulation. But again, everything is happening on the client side is one thing to understand. Deployment wise, what happens is while we are coding and the developer pushes a JavaScript build is created, JavaScript, HTML, CSS, a build is created on your build environment using the environment and the secret. Again, the secrets and the environment have to be passed in the build phase, as opposed to multi-page application. In the multi-page application, because everything ran on the server, you had access to the environment variables and the secret on the server-side environment. And as you can see here, we don't have any server as such to fetch the JavaScript bundle. the secrets and the environment variable have to be injected at build time. So once the developer pushes its code, it goes through a test and build cycle in which the secrets and the environment variable are injected to your bundle.
I think we lost somebody.
Uploaded to your
We lost you, Shubham, for 10 seconds.
okay. Where do you lose me at?
You were talking about the build cycle. So during the build
Yes,
phase,
yes,
how the
yeah.
environment variables are injected.
Yes. So secrets would get injected and then a build gets created and that build gets uploaded to a static storage. So it could be your S3 bucket, you could put it in Nginx, or it could be a CDN as well, where you could store your static assets. And then whenever the user hits your URL, those assets are fetched directly from the cloud. So this is how a typical client-side rendering or single page application architecture looks like. So let's evaluate this architecture on the NFRs that we
Cool.
just talked about.
So just to add on to what Som has already has covered. So the subsequent request. So for example, the user interaction that Som talked about. So there could be use cases wherein you would want to fetch additional data before loading your screen. So for example, if you're building a search page, right? If the user is searching something, you actually go make an API call to the backend, get that search data, present the data back to the user. There would be some APIs. You can create any sort of APIs. So any HTTP based communication essentially. So you would have those APIs in place, which would actually fetch that data from server, and the SPA would again take over from that and build a presentation layer on presentation layer again. So this essentially is a complete workflow for an SPA. Now the static assets that we talk about, again, those would be hosted in S3 and the API. So you definitely need a server for handling the API requests. The static assets could be stored in as Som said, could be stored in an S3 bucket, or you could have a cloud storage like CDN. Cool. Moving on to the evaluation.
Yes. So SEO is bad. Anyone wants to guess or tell why SEO is bad for client-side rendering?
Because the application is not getting HTML directly. It has to wait for that.
Exactly. So SEO is like an Achilles heel for a single page application, because everything is happening on the client side and the crawlers expects an HTML to be there before it starts indexing. So there are ways in which crawler indexes a single page application.
So even though the Google bot, so the crawler or Google bot, that's roughly the same. Even though the Google bot has evolved over a period of time, so the previous generations of Google bots were strictly agnostic to JavaScript. So they did not understand JavaScript at all. So only if the page had HTML, they were able to fetch those keywords from it and actually index those pages. Over a period of time, the Google bot has also matured, wherein it actually is able to run JavaScript. So even if you are building an SPA and the full initial load does not have a full-fledged HTML page, instead it has just a static container page with links to JavaScript, it is able to execute that JavaScript in a Chromium-based environment and then run its indexing on top of that. But this is additional resources for the Google bot. So depending upon the complexity of your website, depending upon how large your bundle size is, depending upon how much JavaScript needs to be executed, the Google bot has to allocate resources to actually execute JavaScript and then figure out what are the keywords from there so that it can start indexing. So even if the Google bot has advanced over a period of time, it depends upon how much resources the Google bot decides to spend for your particular website. So the Google bot is going to have some limited resources. So what they have done is they have they have put hard limits on as to what is the amount of JavaScript that they are going to evaluate, what are the number of pages that they're going to crawl. So that becomes an Achilles heel for SPA. So even if the Googlebot is able to execute JavaScript, there is no guarantee that all the keywords and the SEO is actually going to be very, very awesome for an SPA to start with. Now there are techniques to get around it, but out of the box, the SPA is not going to be good for an SPA. SEO is not going to be good enough for an SPA.
If SEO is a must-have, you need to rethink on. If you have used SPA and SEO is a must-have, you will have to perform additional work just so that the SEO is good. Platforms to support are again, platform support is good. You can run single page application on almost all the browsers, IoT devices, mobile, anywhere you can install a browser, or on any platform where a browser could be installed, you could have a single page application. Security is again good. All these attacks are possible, but again, there are solutions for it. Compared to server-side rendering, there are few attacks that are possible. Which could because everything is on the client side, your code is exposed. What the network calls that your application is making is pretty visible in the browser. You have to take additional care when it comes to the security in an SPA compared to a multi-page application. Development experience wise, it is pretty good. So framework support is very good. You have very good client-side rendering frameworks like React. You have very good libraries like React and Vue. Angular would be a framework. So overall community support is very good for building client-side application. You have Webpack, which has evolved over the times. If you go back in time, there were bundlers like Grunt, Gulp, which were more complex than today's Webpack. Even Webpack, if you go back 5-6 years, Webpack was also pretty complex to use. But with Create React app and even Angular bundler, it is pretty easy to build and deploy. Build those static assets which would be deployed to your static asset storage very easily. Learning curve depends on people to people, but there are enough resources, courses available for you to get started with learning React and learning Angular. So once you get hold of any of these library, you are good to go with you're good to go ahead and develop a single page application. Managing secrets and variables are not very dynamic. Again, it is part of your build cycle, but it's not very difficult. It could be part of your code base, and then your bundler would just get hold of secrets and inject it in your bundle. Performance again is a mixed bag. So one thing which SPA solved was the overall user experience. Because everything is client-side rendered, the response to the user action is pretty fast. That a complete reload is not required. If you're using AJAX calls, it gives you that ability of refreshing the page on the client side itself. Once you make a call to the API, you get the data. You can refresh your component to show the latest data on the client side itself without making a call to the server. So overall user experience is very good, but the first time user experience is not that great, because if you revisit the architecture, all the static assets are downloaded first in the browser, then you make a call to your REST API server, fetch the data, and then the data is loaded. So the first time user experience is not good, but the subsequent request, because if you have implemented caching, it would be faster because you have everything locally available in the browser, and it will load faster. Again, it is a mixed bag. So if your first time user experience is a must have, then a single page application might not perform as good as you want. But then again, it depends whether you want the first time experience to be good or the overall experience to be good. Does this all make sense? Anything to add on this? Anyone wants to share any experience on this?
So regarding the security of this single page application,
We're getting lots of echo, Mukan.
sorry, is it better now?
Yes.
Okay, sorry. Regarding the security of those single page applications, like, is it, I mean, I just read about it. Is it that security is somewhat compromised in some of those frameworks, or how is it? Like, are there some frameworks which are getting new, I guess, versions which are more secure, or is it in general that they are less secure than the server side rendering applications?
Okay, I think we lost Swam. Okay, so it again depends upon the type of framework. So things like XSS attacks, wherein people can actually embed scripts inside a text box. So XSS attack is where, if, for example, if you have a text box on a web page, instead of typing say hello world, I say script open open parenthesis close parenthesis, I say alert ABC, and when I execute that, the browser is actually going to execute that JavaScript and do something else. So this kind of attack is essentially an XSS attack. So all the modern JavaScript frameworks, they so very attacks similar to these, which like CSP, XSS, or CSRF. All the modern frameworks, they have gotten around this. But again, it depends from framework to framework. So React, if you consider it, by default stringifies everything. So the scripts, JavaScript, they are not going to execute in your DOM elements.
Okay.
But again, it depends from framework to framework. So one thing that Som actually talked about is because with SPA, the build has to have everything. So the environment variables. So for example, if you are talking to third-party APIs and you need API keys to talk to those third-party APIs, and those API keys are different across different environments, your builds have to have those API keys. So when I say your builds have to have those API keys, that means the JavaScript bundle that is getting downloaded on the client browser, if you ever inspect that bundle is going to have all those environment variables baked in. Why? Because there is no server element to it. The bundle is directly served to the browser, and it is up to the browser to interpret the user actions. So that becomes a security consideration. That what things do you want your front-end application to actually do?
Okay.
But it again depends upon the type of implementation. You can again mask these things by implementing these things on a server side rather than a client side. So in this case, the example that I talked about, it's a misplaced responsibility. So something that should have been done on server side is done on client side, which has led to all the secrets getting ready for the user to actually see.
Okay.
Understood. Even authentication. So
Yeah.
if you are having a login page which is client side, again, it is an example of misplaced responsibility where you're making a post request with username and password from your application. So that would be an additional responsibility on your application if you have a login form in your page which is making a call with username and password to your server to create an account or login. So these are the things, again, with multi-page application as well, you would have to worry about them, but because everything is happening on the client side, you would have limited options of actually implementing things in that regards.
Okay, thanks.
My question is like, initially requirement was like very less, and initially we developed like small level of application, but at the over of the period, the application itself becoming a large. So at that time, what we can do? The example is the React itself, right? So initially we decide like we have like 4 or 5 pages initially, but after 2 or 3 years, it becomes a very big application. So at that time we thought like, could we choose the Angular at that time? So we can overcome of this problem. So what will be the solution at that time?
It is not very related to the architecture pattern that you use. So again, it is more on code maintainability part. So if you are I mean, anyways, you're going to start small with 4 or 5 pages. It depends on how you're structuring your application and how easy it is for you, for the developers to navigate through the code as the code grows. And again, I mean, there is a different architecture style that we would be discussing towards the end, which tries to mitigate the scale part as the application grows. We would get to that, and you can hold on to this thought for a few more minutes. We would be talking about an architecture pattern which solves the problem that comes with monoliths. If there is nothing else on this, let's move on. So there are these are the 3 very popular applications which are using single page applications. So Google Maps is one of them. To verify that, you could open Google Maps on your machine and try to inspect the source. You will not find any HTML at all. You will just find you will find HTML, but you will not find any div tags, span tags in the HTML at all. You will just find CSS and JavaScript imports. And if you open the network tab, you'll see millions of network calls. So everything is driven by JavaScript. So it starts off with downloading all the JavaScript, and based on the user interaction, multiple API calls are made to update the page. So it is very driven. So the application is very driven by user interaction, and for every user interaction, there is a related API call which is updating the page. And because it is single page application, because everything is client side rendered, the user gets a good experience. The user does not experience any flicker, as opposed to if Google Maps was server side rendered, then it would not have been easy to actually give that kind of experience. So if we zoom in or zoom out, we are at real time seeing different places that are there in that area, different streets that are there, and there is no flicker that we experience. So that is only possible because everything is getting handled on the client side. Gmail is again an example of single page application. Everything gets handled on the client side. These are few of the popular examples that you can relate to understand how single page application works. And maybe
So if it is very high very high heavy user interaction, that is something that you would want to build, and SP actually makes sense. Even with the things that SP is not so good at, there are ways to get around it as well. But if high user interaction is what you would want to aim, then SPA might be a good choice.
SPA doesn't server end. So SPA would be just your front end part. To answer Ganesh's question, SPA requires server for the data, but it is not. It is a separate team or a separate application that would be implementing those APIs and interacting with the database. So that won't be part of your front end bundle. You could have
Correct. So this application layer that Soham talked about, that is essentially the backing server for your SPA, and that is going to take charge whenever additional data needs to be served to the single page application.
With this, I mean, with this architecture, you can also have a separate front end team and a back end team as well. That it gives you that clear separation between front end and back end. So you could carry on development in different teams as well. If there are no questions on it, let's move on to the next architecture pattern. So what we started off with seeing server-side rendering where everything was happening on the server side. Then we saw client-side rendering where everything was happening on the client side. So both of them had some pros and some cons. So what if we were to mix both of them and get the best of both worlds? So that is possible if you decide to use isomorphic rendering. Isomorphic rendering means your same code runs on the server side as well and the client side as well. So the problems of SEO that we had in client side rendering, because everything was rendered on the client side, the solution for that was an easy solution for that is move that rendering logic to the server side. But if you just move it to the server side, you would have user experience related issues. So the best way, I mean, a good way would be if you are able to execute the same code on the server side as well and the client side as well. So this pattern is called isomorphic rendering pattern, where you are rendering the same piece of code on the backend and the front end as well. So a typical flow of an isomorphic rendering application is something like this. So the user starts off with making a request to the browser. Once that request is reached to the server, it starts off with getting the data, fetching the data. Once the data is fetched, that data is passed on to respective components, and the initial page is rendered on the server side, and that is returned to the browser. The browser receives a pre-rendered HTML page, and the browser then starts the rendering of this page. And this is where after this, the best part of isomorphic rendering kicks in. So after the initial render is done from the server side, the application then moves on to single client-side rendering mode, where everything is handled on the client side. So all the user interactions on that page, maybe button click or applying some filters, that happens on the client side. All the subsequent action after the initial render are handled on the client side. So this is where you get the best of both worlds. Let's move on to the architecture of this. Any questions on this? So this isomorphic rendering is actually mixing both of them. So you will have some rendering on the client side, the initial rendering on the client side, and once that initial rendering is done and the page is downloaded in the browser, you would the application would move on to the single page application mode, where user interactions and data updates are handled on the client side itself. Does this make sense, or I mean, are there any doubts?
In step one, it may not be a landing page, right? It could be any page. Or
It could be any page.
It could be any page. It could be every page.
every page. Yes. Yes.
every
So,
page.
It could be
And
every page. Yeah.
an ideal isomorphic application lifecycle would be if you hit any page, let's say XYZ URL, if that page has been previously visited or cached by the browser, it will not make a call to the server. It will just use the code that is there in the cache and start rendering it. Just because the ability of the code to run on the client side and the server side. So, again, if the page is not already cached and downloaded in your browser, it will make a call to the server, where the server will pre-render the code and return it to your browser. So you get the advantage of both worlds. The problem that we saw with client-side rendering was the initial page load, because it had to download all the static assets and then again make a call to fetch the data and then render the content. That part is completely offloaded to the server for the first time, where the server just pre-renders everything and returns it to the browser. The problem of initial load gets solved because of server-side rendering, and the problem which was there in multi-page application, where for every user interaction it had to make a call to the API. Yeah, that gets solved because after the initial load, the application moves on to the client-side rendering part, where it utilizes AJAX calls to actually update the pages and fetch the data.
So this architectural style was actually possible with the advent of Node.js. So Node.js by default has the capability of executing JavaScript, but again, it does not have access to the window object that the browser is providing. So if you have a Node.js backend server, it can actually interact with APIs, maybe make database calls, or maybe call multiple third-party APIs to actually gather and aggregate that data. And post that, because it is Node.js, it can actually execute JavaScript. It can actually take that template and hydrate that template with all the data and give that entire payload to the browser. And the browser can essentially take it up from there, because the browser has HTML and the entire JavaScript bundle. So all the user interactions can again flow from there. So this was all possible with the advent of Node.js.
So the Next.js is doing the same, something like that.
We'll talk about Next.js we'll talk about Next.js. Yes.
Okay.
So yes, Next.js is again, yeah.
It is an ISO. So it is essentially you can do an isomorphic application using Next.js. There are also frameworks like Svelte, which are also tailor-made for doing these things.
Let's move on to our evaluation of isomorphic.
Yeah,
And
I'm sorry.
Yeah, so like we discussed, so SEO is again, SEO has turned green now because the crawlers are happy because they're getting pre-rendered HTML. Platform to support are again, I mean, isomorphic is good. Using isomorphic will not hamper different platforms. It has the same security concerns that we would have with multi-page and single page. One thing which is challenging here is thinking in isomorphic way, because now you have the same code that runs on the backend and the front end as well. So a learning curve, it might not be steep, but again, there is a learning curve wherein you have to understand that the same code is going to run on the client side and the server side, and be aware of it and write a code in such way that it doesn't break. So one example for that is, on the server side, you don't have the window object, and on the client side, you won't have access to the environment variables. So if you are accessing the environment variables, and if that page was client side rendered, you would not have access to them, and vice versa. If that page was getting rendered on the server side, it will not have access to the window object. So these are the considerations that you have to have while developing your code or writing your components. Maintainability issues are going to be there. I mean, it depends on the size of your team and the kind of application that you have. As the team grows, isomorphic will have the problems that every monolith application has. Framework support, coming to framework support, there are good frameworks available. Next.js is one of them. Svelte is one of the framework which we just talked about. Meteor was the very initial framework which came up with isomorphic rendering, which allowed your code to run both on front end and back end. You need some team maturity. Again, I mean, like we discussed, it is because the code is rendering both on front end and back end. You need people to understand this and then develop the code accordingly so that it performs well. And there are no unexpected bugs, or I mean, the code could break because you were not aware that it's on front end and back end. So those kind of problems might arise if the team is not mature and not considering all these things. Apart from that, I mean, using isomorphic is giving you best of both worlds. It is giving you good SEO. Along with that, it is also giving you client-side rendering, which gives a good immersive, rich experience to the user. But the cost for it is, the con for it is, you need to learn isomorphic techniques and then implement it in a way that you are getting advantage of isomorphic or universal rendering.
One additional complexity for an isomorphic application is also debugging. So if you are actually trying to debug some complicated issues, because partly the page is getting rendered by the server and the remaining actions are getting triggered by the client, and again there would be REST APIs or some HTTP based APIs which would be fetching data from server. So debugging some issues might be a little tricky. So you might need to build some additional tooling to get around it. I mean, there are ways to circumvent those problems, but debugging by default is going to be a little more painful.
Not as easy as just putting.
Not as easy as an SPI. Yeah.
Just put a debugger and
correct.
You developer tools. Any questions on this? Anything to add? Anyone wants to share this on isomorphic? Someone mentioned about Next.js. So any experience on Next.js?
Yeah, yes, like I have built an application where like it is not built up at the build time. So like you can add a product and a product will appear on the website, and so it's like it will be on the call time basically. So request time basically. So that's how, yeah. So
Do you
I
have any
used
learnings that you would,
Next.js.
do you have
I-
any learnings that you would want to share?
Yeah, like oh, I was using CMS, basically Oracle CMS. You might have heard about it. Yeah. So the only problem was that I was facing some problem at basically header, or because in the app.js you can't call earlier, as far as I know, you can't do that server side rendering. So I could not able to like do the header thing at Next.js, and when I was doing it was sometime and was not working. So I have to implement in my client side. So the header is only thing which is like which I built using client side. Other than that, everything was server side rendered.
Cool, cool. Again, this is an example of the learning curve that you have with isomorphism, that you need to learn the framework that you're using, understand what isomorphism is, how things get handled both on the client side and the server side. Cool, cool. Let's move on to the next slide. So Airbnb and Twitter, these are two very popular applications using isomorphic pattern. Twitter has an interesting story. So don't have the link. I'll towards the end or after this slide, I'll share that link. So Twitter actually started off with single page application, and as time passed by, they obviously found that their SEO was not pretty good, and it took going back to client-side rendering. This client-side rendering requires you to download the assets and then render the page. So there was some delay in rendering the page. So they ran an experiment in which they calculated the time required for a user to reach the one tweet page. They started off with showing the list, tweet list, and then they calculated the time required to reach a particular tweet, and they ran both, I mean, single page application and isomorphic, or I mean, they started off with server-side render application, and what they found out was the time required for a user to reach that a particular tweet was way less with multi-page application as compared to client-side application. And one thing which came out of their research was because they were doing server-side rendering, the page load time was reduced to 1/5 of what it was when they were doing client-side rendering. So again, I mean, if you want fast page loads, isomorphic or server-side rendering could be a better choice. I'll after this, when we move on to the next slide, between that, I'll share the link which has complete information of Twitter's journey of moving away from single page application to server-side render application with some JavaScript enhancements in it. So
Correct.
these
So
are
even
two of
even
the-
if you go ahead and minify your JavaScript bundles, even if you go ahead and gzip those bundles, serve them over CDN, there is still an additional delay because even after those JavaScript bundles are downloaded on the client browser, the application is going to make some HTTP API calls to actually paint the data. Until that time, the only thing that user is going to see is a loading indicator. Now you can go ahead and implement a shimmer effect or some skeleton loading page, but the ground reality is the data is not available for the user. So that was the prime motivation for Twitter to go ahead and experiment with isomorphic.
Yeah. Any questions on this? Anyone wants to share any of their experiences, learnings on completely? I mean, we could consider multi-page application, single page application, and isomorphic application together. Anyone wants to share their learning, their experiences working on these architecture styles, if they have worked on this?
So I have a question, as in how relevant it is to consider a performance of loading when it comes in the today's world of technology, where bandwidth is, we have high availability bandwidth and modern browsers and devices. Does it being still considered?
Yes, yes. Again, I mean, if you are creating a client-facing application, so there are two things. So one is eventual user experience, which you cannot actually fit in those web vital numbers. So web vital numbers might be bad, but the user is not experiencing slowness because maybe the loader, or you might have implemented few transitions, which is keeping the user engaged. But again, if you have a client facing application, or I mean, an application where which you want which you which you want to uh, reach to multiple clients, multiple users, SEO is very important to have, because that will make your application discoverable on the search engines. And to have good SEO scores, having a good page loading performance is mandatory. Even having a good mobile experience is mandatory for having good SEO. So if good, I mean, if page ranking in search engine is a must have, then fast page load is mandatory. I mean, that is also a must have.
Okay.
So again, I mean, you can divide it into two things. One is the eventual end user experience, and the other one is SEO. So if SEO is important, then page load is very important. And if SEO is not very important, then you could ignore page loading times.
Okay.
There is also a technique called pre-renderer that was very popular some time back. I think it is still very popular. So what that does is so because of the advent of SPAs, right? So a lot of companies, a lot of applications had started using SPA. Soon to realize that SEO has been compromised. So what pre-render actually does is, so the way Googlebot works is it tries to figure out if you have an HTML page, and then it will start indexing based on your keyword. It will try to figure out what the performance is for a mobile website, for a normal website, what is accessibility, and based on many more metrics. I'm just abstracting down a lot of them. It will actually figure out what is the raw score for your website, and that will essentially go ahead and back to your SEO. So what a technique called pre-rendering does is, it is tailor-made again for an SPA application, that you actually serve a tailor-made HTML page for the web crawlers to actually work. So you still serve your entire SPA, that is a single page application which will have all the JavaScript bundles for a normal user. But when the crawler actually tries to crawl through your application, you actually serve a templated HTML page. So that way you still get the benefits of SEO, you still get an optimized experience, you still get your SEO score relatively high, and you still get all the benefits of SEO as well. Again, this has its own drawbacks as well, but that is a technique that was also popular some time back. Yeah, I think so much talk. The Twitter journey that so much talked about, that is the link that is pasted in chat. Cool. Do you have any questions on whatever we talked about till now?
Just a related question. Like I went to a meetup where 1mg people were talking about that. So what they were telling that that SEO rank was low and it was not coming out the page one. So what they did something on the basis of user agent.
Okay.
Like if user agent is the bot, they'll not show their images and videos. They'll only show the textual data.
Yeah.
And
correct. So that is the technique called pre-rendering that I talked about. So the way web crawler works is there will be a file called robots.txt inside your bundle. So what the Googlebot does is it will start interacting with the robots.txt file. It will try to figure out what are the different assets that you're actually loading. And then it will start crawling different assets. So what you can do is you can make a tailor-made robots.txt file, and instead of giving the entire website, entire preview, you can strip that website into the HTML preview that I talked about. So the HTML preview that you give to the crawler might be a very dumbed down version of your website. You can strip videos, you can strip graphic content, you can strip any animations, you can even strip all the JavaScript, but it can still have the basic HTML page, similar to a light web page or if Flipkart Lite is something that you've seen, similar to that is the experience that you would want to present to the crawler. So the crawler is again happy, the SEO again ranks good, and you still can work with an SPA.
Oh, okay. All
So,
right.
yeah, so that's a technique called pre-render. So just Google prerender.io, and I think that should talk about the same thing.
Okay.
On this, I'd like to share one of my experience on previous project that I was working on. So it was built on Drupal, which was, I mean, SEO by default, and everything would get was eligible for SEO. And unfortunately, that application was for lawyers, and we had a page in which the lawyers were making notes of their work and adding details about their client. And because everything was SEO by default, the page in which lawyers had put some confidential notes was actually indexed on Google. So as part, I mean, we never, thought about it, and even we did not catch it. But one of the testers on the client side actually just Googled the content that was posted in one of the notes, and that showed up in Google. So that is also one NFR that you should consider if you are working with some private data. That should not be indexed. So again, if you're using something which is SEO by default, you have to make sure that you're disabling few of the pages which are showing personal information or medical information or any PII. If the page includes personal identifiable information, that should not be eligible for SEO.
So basically, like no index, no follow for that page.
Yes. If you were to use client-side application, client-side rendering, that would not get indexed at all. If you have that could be a use case of using maybe client-side rendered pages to avoid indexing completely.
Cool. It's 11:35. Okay, let's move on. We have like an hour. Okay, where is my cursor? So the next architectural. So we have talked about only server-side rendering. We have talked about only client-side rendering. We have talked about mixing both of them in an isomorphic way. So essentially, these are the primary three architectural styles that are actually available, because there's only three things that you can do. You can either render it from server, you can either render it from client, or you can mix and match two. The remaining two techniques are actually optimizations on either of the architectural choices that you make. So Jamstack as the name, so the abbreviation Jamstack is JavaScript, API, and markup. So that is why they collaborated as JAM. J stands for JavaScript, A is API, and M is markup. So at the heart of JavaScript, for Jamstack is something called a static site generator. So Jamstack is an extension to an SPA architectural style. SPA as in single page application. So where single page applications lack is they don't have pre-built HTML pages. That is why SEO is so bad. So think about that is where static site generators actually start come into picture. So what an SSG actually does is it tries to create or build those pages at compile time. So I'll actually take an example. So think about something like gsmarena.com, right? So if you are going to this guy and look for whatever you want. So for example, I want to look for Apple 12.9 and what are the specs for that. Now this website, so this web page seems dynamic, right? Because the type of mobile device that a person can choose again depends upon the search filters. But having selected Apple 12.9, the specifications that I see over here, are these specifications ever going to change? So what is the frequency in which the content is actually going to change? So if I look at this page, there is an image over here. I talk about some high level specifications. I have some detailed specification down the screen, and I have some comments. So let's leave comments for now. Leave out comments for now. But apart from that, the entire page, once this page has been built or once this page has been rendered, is this page ever going to change for any different user? So even if you log in from say China, this page is going to look exactly the same. Take another use case, something like a blogging website, right? So I hope Frank Bush knows, okay, this is a blog that I'm trying to make. The content of the blog, once the blog has actually been published, is that content ever going to change? Now, I agree that content is going to change, but what is the frequency of that content changing? is, are you going to update that blog every second? Maybe not. Are you going to update that blog every 5 minutes, every 10 minutes? Maybe not. Are you going to update that blog maybe once a week? Why? Because there could be some comments that actually specify that some content needs to be moderated, some content needs to be changed, needs to be pruned, something of that sort. So the frequency at which the content is changing, the cadence is very, very low. So this becomes the prime candidate for a static site generator. So what SSG essentially does is, so there would be some frameworks that will essentially help you do that. At build time itself, whenever we are building our assets, we would start building these web pages as well. So I hope Frank is okay. So the whatever the web address of this guy. So I hope Frank is okay. -c blah 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 whatever this address is. I'm going to pre-bake this page and keep it inside a public folder. So what happens is anytime someone wants to access it, the page is directly available on my web server. So the server does not have to render dynamic content. The client does not have to render JavaScript. Whatever HTML is present, the client the browser just has to present that information to the browser. So that takes care of that takes out a lot of code from server as well. So imagine if this was done as an SSR, right? So every time a user is going to try and access this blog, I'm going to access this information dynamically from some place. So I understand that even if this is a blog, it has some structure associated to it, right? So it has a title, it has some content, it has some images. There could be some code snippets that are shared, that are getting shared. There could be links that are shared. All this content is dynamic. I completely agree with that. But once this content is actually hydrated with the template, so the template being that a title goes on top, the content goes over here, the image goes over here. Once it is hydrated with the actual data, which you can fetch from any database or whatever store you would want to use. Once this template is hydrated, is that template ever going to change? So if we had done this using an SSR, we would always be fetching that data, fetching that template, hydrated, send it back. Fetch that data, get that template, hydrated, send it back. We are going to doing the same operation over and over again. If it was SPA, the browser is doing the same thing again. It is the template is present directly in our Webpack bundle. We fetch the data from an API and we again massage it, hydrate the template, render it back. So we are doing the same operation over and over again. So these become the prime candidates for a Jamstack based implementation. So the static site generator over here, this will take care of those things. So there are frameworks like Next.js wherein we can actually connect to a database at build time itself. So whenever we actually push the code, the static site generator is so in a nutshell, SSG is a program that is going to crawl through all your templates. If there is some dynamic data that needs to be loaded, it will fetch the dynamic data, hydrate it, and store it in an HTML page. And now this, whatever hydrated templates we have, we can directly push them on CDN so that they are readily available. So that's a technique called Jamstack. Does it make sense, whatever I talked about? I take that as a yes. So what it solves out of the box, right? Because a majority of the pages are pre-built, my SEO is sorted, right? So if I go to my evaluation, a majority of the pages are actually pre-built. So I get SEO out of the box. I don't have to do any additional logic for SEO. I have also offset a lot of my server work, right? Because there is no need for anyone to actually hydrate those templates and render it back. So my infrastructure requirement can also go down. But the reason this guy is still in yellow is because there will be some provisioning for the static site generator. So at build time, so what we have done is we have offset the runtime cost at we have offset it towards the build time. It is still acceptable to have that additional cost at build time because you are going to build all those assets only once, but you're going to serve those assets multiple times. And if the assets are exactly the same, your runtime costs actually goes down. Your build time cost might actually go up. That is why this guy is in yellow. Performance wise, because we actually render fully loaded HTML templates, the browser is very, very happy because the browser does not have to spend time in executing the JavaScript that is available. So the browser is very, very happy. When it comes to developer experience, because this can be so I have abstracted down a lot of concepts of static site generators by just saying that this is just a magic box which is going to compile stuff for you. There can be additional complexities to it. So for example, the blogging website that I talked about, right? For example, the Medium blog that I talked about, there could be challenges in fetching that data. Fetching that data might require some authorization or some authentication tokens or some cookies to actually get that data from. So there might be some additional complexities over it, which will have to overcome. So that is why the developer experience is a mixed bag. And again, you have to start figuring out, again, there would be a learning. If you are doing all of this by hand, you'll have to implement a majority of the stack that I talked about will have to be implemented by hand. So there are frameworks like Next.js, which nail the entire developer experience. So with Next.js, every template that you build, the framework is going to ask you as to what things you would want to build at build time and what things you would want to render at server time. So again, there is a learning curve involved in understanding how Nest.js actually work. But once you have done that, Jamstack actually runs pretty fine. When it comes to security consideration and platforms, it is because this is just an extension to a single page application. So whatever we did for security and platforms, it is roughly the same for a Jamstack implementation as well.
Question.
Go ahead.
You earlier mentioned like you skipped the comments part in the GSM Arena page.
Correct.
What if
That-
we want to? Okay.
Correct. So that is why I said that Jamstack is an extension to SPA, right? So why we skipped comments? Because comments is something that has to be loaded at a dynamic interval. So even if you create a pre-built template for this entire thing, we can still add a template for this guy and let browser do whatever it does best when it comes to an SPA. So the remaining part can still work like an SPA.
So it's like partially
rendered template. But with SPA, you had nothing to start with. With Jamstack, you have 90% data pre-rendered to start with, and for the remaining things, you actually load these things at runtime. Because this data, the frequency of comments getting changed is very, very high. Similarly, if you're building the likes, for example, if I have Medium blog, right, there would be some place wherein I'm actually saying what are the claps, how many people have liked this blog, how many people have commented on this blog. The frequency of this data getting changed is very, very high. So that is why it makes sense for this to be SPA. Similar to something like a Google Maps. It is a very highly interactive application. So the frequency of someone typing something else or zooming something in or zooming something out is very, very high. So it does not make sense to pre-bake it because we don't know what the user is going to do. So these things would still be handled by the SPA. So that's why I said Jamstack is an extension to it towards an SPA style of doing things.
That's good.
SPA thing would be an enhancement. So majority of your page is pre-rendered, and whatever is not the kind of, the sections of the page or the data which is not possible to be pre-rendered, add an SPA enhancement in the page. So whatever dynamic information or parts of your pages which requires an user interaction could be a React component or an Angular component, which then again falls different APIs.
Some popular examples are Audible. So if you just go to audible.com or Louis Vuitton or essentially any CMS, so they are prime candidates for the Jamstack-based implementation. And of course, you don't have to do a lot of heavy lifting on your own. There are frameworks. So there are frameworks which are dedicatedly made just for solving the static site generators problem. So Next.js is amazing at doing it. There is also a framework called Hugo, which is also a very good static site generator. And again, it's open source. You can again latch on to different SSGs and figure out how you can build these things at a compile time.
Yeah.
So, good.
Sorry. Yeah, one of the audience have asked a question in chat. What about localization?
It still says the same, right? So if I am only catering to 3 different languages, so for example, I'm catering to Espanol, Japanese, or this, How would you handle that in an SPA? You would have dedicated templates for those three languages. So you'll have something text Japanese.yaml, .html, Levendex Russian .html, something like that. You can again pre-bake those using this. If those things are going to stay, if the frequency of changing those things is not very high, you can again pre-bake those things. And again, the remaining complexity will be handled by the SPA. So if you're just building a simple CMS application, you can actually get around without even having a server. You can serve the entire thing on a CDN. So something like Netlify, if Netlify or Gatsby, if you have explored these are tailor-made framework. These are tailor-made applications using Jamstack. So what they do is, if you're actually building a CMS, so something like Audible.com or GSM, something like this guy, Audible.com. Right? So if you're building something like this, so this is entirely not this one. Sorry, Coupon supplier, something like Louis Vuitton.com. Sorry, this is behaving a little weird. I think I forgot the name of the website. So this guy is this is a very dynamic content. Something like, yeah, this one. So if I have to just search for, say, bags for men, for example, this is again a very static content. All it has is a bunch of images, and that's it. So it makes sense for these things to be pre-built. There is no need for you to have to waste any server power for maintaining these kind of applications. Even a part of e-commerce applications can be solved using Jamstack, wherein you have some static content and some content that changes very frequently. If there are no questions, we can move on. Okay. The last architectural side that we are trying to talk about is micro frontend. Again, so this is not an architectural style in itself, but it is. So if you have worked with a monolith-based application, right? All the complexities that you have with a monolith-based applications is the exact complexity that you will have if you have a monolith application just for a front-end based library. So imagine working on a code base for front end of Flipkart.com, and all the code base is in one Git repository. So all the complexities that you had with a normal monolith application, you would inherit all those complexities. So what micro front-end approach tries to do is it tries to break different verticals out of the same application. So for example, if I talk about draw.io, which is just a fictitious website, what I've done is different sections of these websites are actually different verticals. So for example, even if I go to, say, flipkart.com, I can see, so cart essentially can have its own complete life cycle. The search box and the thing that it actually renders can be a complete life cycle in itself. The filters over here can be a complete vertical life cycle in itself. So what we have done is, what we are trying to achieve is, we are trying to divide the same application into different vertical namespaces. What you've done is, like, search can live alone. So anything that has to do with search, it could be the APIs, it could be some front ends, it could be some JavaScript. All that can be isolated in one unit. Similar thing, the things like shopping cart, billings, checkout, that can be abstracted out to one particular section. There can also be sections like recommendations, which are based on heuristic analysis of what things you have bought online. Those can be abstracted out into different sections. So what micro frontends try to achieve is, instead of having one big bundle which serves everything, we try to divide that bundle into different business verticals that make sense. So when I say business verticals, they have to be isolated enough so that they don't step into each other's toes, but they can actually sustain on their own. The reason this works at scale is because imagine like 1,000 engineers working on one code base in one Git repo. And if it is HTML and CSS based code, imagine the nightmare when someone changes one CSS rule at one particular place. And it is only when you actually deploy your website, you'll actually realize that, oh, something has actually broken. So the problems of scale can actually be addressed by micro frontends. This is also something that similar that Chintan was trying to ask. That you started with something very simple. The website started getting traction. You have lots of features that you're trying to build. Because you're actually building a lot of features, you've actually started increasing your developer base as well. So essentially, all the problems of scale start impacting you. So what the architecture says is, you subdivide your entire application into business verticals, like business vertical 1, 2, and 3, and you can have separate build and test pipelines for either of them. So say micro frontend A has its own artifact, B has its own artifact, C has its own artifact, and we can compose these three sections at runtime. Now, composing these three sections at runtime can have different strategies. The simplest strategy being an iframe based approach, wherein I can have micro websites for, say, search, checkout, and recommendations, and I can load them in individual iframes over here. That's a very crude approach, but it can work for simpler websites as well. There are other approaches to actually composing different micro frontends. But that's not the primary intention of this talk. So if you want to understand more, we can talk about them more. So if I go to if I go to evaluation for this, the development experience becomes a mixed bag. Why? Because you have to understand how micro frontends work. You have to understand how composition of different micro frontends can be done at different levels. You can compose them at build time. You can compose them at runtime as well. Again, it depends upon what you want to gain into. Rest all the requirements there is so there are a couple of things which I've already created, things like SEO platforms, because it again depends upon the type of things that you are used to render. So if, for example, micro frontend A can be an SPA, micro frontend B can be an isomorphic application, and micro frontend C, which is this guy, can be a Jamstack. So it can be a hybrid approach that you would want to take. It is also possible that you use different technology stacks for building this. So micro frontend A can be built out of AngularJS, B can be built out of React, and so you can use something like Svelte. So there is nothing stopping you from implementing or having different frameworks or different architectural styles for building different micro frontends. So the power that it gives you is there is a very loose coupling in different applications. You can scale your teams independently. Different teams can work and manage their own code base very effectively, and everything can still work just fine. But again, the complexities of this is, again, you have to ensure that because everything is run, because all are different smaller applications, and it is only at runtime that you will understand that some applications are behaving or not behaving correctly. So there might be some additional strategies for that you would have to employ when you're actually testing these applications.
How to divide the front end?
So it again, so that's what I said. It should be done according to the business vertical. So it cannot be a developer call. It can be a developer call, but it has to be influenced by a business vertical. So for example, the recommendations that I talked about. So if I'm searching for iPhone 14, this is what I get as a recommendation, right? Reviews of popular mobiles. I can see iPhone 14 Pro, Starlight, different colors. This guy is actually independent of what I'm doing over here. This guy over here is actually independent of the cart as well, because it does not need any information from cart as well. So this application can actually live on its own. The backend for this can again live on its own. So this entire vertical can be carved out. So you can actually have something called a recommendation engine, which will have a front-end aspect to it, which is this widget. It can have a backend aspect to it, which could have the APIs that are necessary to support this. And again, it can be an SPA, it cannot be SPA, it can be a decision that you can take at any point of time. So these are the candidates. So the entire business verticals have to be carved out. There could be things like, see, flights. There's flights as an option over here. entire flight, whatever these guys have built for flight, can be a different micro front end in itself. But at runtime, whenever we load Flipkart.com, it all looks very, very cohesive, right? So what they have done is they've actually composed all these things at runtime. So the entire management of how you book a flight from where to book to where to book, figuring out what the ticketing details are, actually reserving things. This can be a complete different micro front end. And actually it will be a different micro front end for even for Flipkart's implementation. They've just linked it over here.
I mean, actually, I was more interested in when not to split. So if you have.
So when not to split. So if there are a lot of interaction, so things that a common packaging principle is things that change together have to stay together. For example, if for every filter that you apply over here, this search criteria is actually changing, right? So if we actually go ahead and implement this filters as a different micro front end and this search bar as a different micro front end, can they actually stay independent? They cannot. Why? Because every time I make some changes over here, this guy has to be repainted. Every time I make this change over here, this guy has to has to be repainted again and again. What I mean by repainted, this search, so from a front end perspective, there has to be a lot of communication between these two components. From a back end perspective, the search box is heavily dependent upon what filters you've added. So the APIs that are rendering your search filters, they are again dependent upon your filters. So if the namespace of the APIs and the entire front end is are working as two independent modules or two independent micro front ends, all they are going to do is talk to each other or depend upon each other at every point of time. So things that stay together have to be together. Things that change together have to stay together. So by that principle, it does not make sense to break these two things, even if they look a little different on the front. So that's why I said it cannot be a pure developer call. It has to be a call based on the entire domain that you're trying to implement.
Okay.
Also try to think about from this perspective that what happens if the search is down, right? Can you still add things? Can you still check out your cart if search is down? You can, right? Because if you've added 3 things in your cart already and you're still not able to search, but you can still book the products that are already available in your cart. So this is not stopping you. So these things actually look independent. Searching something and checking out something are two different business verticals in itself, even if they look very cohesive from a web page point of view. So they can actually live separately. Things like becoming a seller. So even if Flipkart is down, there is no reason for me not to get onboarded as a seller in Flipkart, right? So seller application can actually live independently of the primary Flipkart site. So it can be a different micro front end or a full-fledged front end itself.
Another example could be Facebook, right? The chat functionality, for example, it's totally independent of your feed. Recommendations and all of those things are very independent of the feed. They can go in a different micro front end. And if one functionality is down, the other would still continue.
Correct. So micro front ends are two front ends as it's an analogy. You can still apply as microservices are to monolith. It's a very, very similar analogy.
Yeah, I'm just thinking out loud that a lot of microservices do's and don'ts would also apply here.
Yes,
These
yes,
data
absolutely.
coupled together, but they should
Correct.
not be split out into separate service.
Correct.
Avoid chatty interfaces and this.
Yes.
One thing which I did in the past is just don't do it for the heck of it. I mean, just because you want to have micro front end and separate out things, just don't do for that. I mean, I remember we were just team of 4 and we created 3 microservices, and then eventually it was a headache for us to actually think in microservices term for a feature which was actually very related. So even if you're one team, I would say don't start off with thinking in terms of microservices or micro front end. Just start small, and then as the project team grows, you could take that decision later.
Yeah, just to add 2 cents on the micro frontends, I explored that in my previous organization with the Next.js and Model Federation for React, and it was not a good experience working with micro frontends, and it was because of lack of toolings around that, and the way entire business logic was like it was too difficult to share the state between different micro frontends. If you have a business light applications, then micro frontends would be possible choice. But it was not a really good experience with micro frontends.
So there are again different strategies for maintaining states or maintaining comps across different micro frontends as well. So there are libraries like Postal.js, which actually which is again a very it is a very similar implementation to AMPQ. So you can actually resort to. So again, the moment you start delving into micro frontends, you'll have to think about what are your communication strategies, how are you going to share state between two different micro frontends, how are you going to build them, how are you going to deploy them. So all those challenges start coming to. That's just something never start with micro frontend.
Yeah.
I'm keen to know your thoughts on why model federation did not work well for you.
Model Federation was too early. Like we explored 1.5 years before, and we also consulted with Zach, the one who created this plugin, right? He's pretty active, but the confidence we got when we dwell into the actual code of Model Federation plugins with him was not built with the strong foundation. He himself, that means me and my team basically experienced that he himself is not really confident and trying to upsell something which is not really stable for the community or for public use to build large applications, because the plan was to build the micro frontends for big fintech application which has a banking side and the public facing side. The public facing side requires SEO and everything, and the banking side is post login flow where you see the typical banking application with all investments and everything. And in fact, we paid for his consultation, but the answers we got, how it works, what is the future, was a bit not really clear for us based on the interaction. And so we decided to drop the Model Federation idea, and we started exploring Next.js with zones. So Next.js also comes with the feature called zones, where it's basically, they call it as micro frontend, but it just separate routing on different URLs, and at the end it's hosted on the same domain. So for end user it feels like a micro frontend, but it also comes up with the its pros and cons. We were not really ready to sign up with the Vercel for deployment, because Vercel said they cannot guarantee that the PII data will not be exposed during the build time. And since it's a fintech, it was really pressing point for us to have that guarantee, that because Vercel runs on the edge, right? So the Lambda, and it doesn't guarantee where your code is executing. Since we are in EU, we wanted to have all edge servers or all Vercel servers executing our builds within the EU at least, and they said they cannot guarantee it. So that was out of question. Then we ended up using AWS for that, AWS services, and with the Next.js latest feature, and AWS deployment tools are far behind with the Next.js feature. So it was not a smooth journey to deploy Next.js micro frontends with AWS.
So what we had done, so we had experimented with micro frontend before Model Federation came into picture. So we had actually built our custom solutions to load those common libraries. So we used to, our container application used to load common libraries, whatever are necessary, common libraries and common CSS, and then it would follow through to all the other micro frontends. Of course, it had some its own coupling, but it is an okay experience. It was not that bad.
Okay, that's good to know. Yeah, that's from my side.
Good.
Does anyone else have any other questions or any other thoughts, any other music that they would want to talk about?
No, don't look like.
Good. It's a wrap then.
Then, yeah, then thanks for good session. Was good to know. And I'm joining from Germany. I woke up at 6:30. I was in Pune for 7-8 years, visited Technogize quite often for many meetups, and Mayank also knows me very well. In fact, I met Anand as well for the interview like 3-4 years before. So good to see you back again after a long time.
Do you have
Yeah,
plans to go?
likewise.
Cool. If that's it, I won't take any of your time. Thank you for joining, guys.
Thank you. Have a nice weekend. Bye bye.
Bye-bye.
Thank you. Bye-bye.
Hey, thank you all for joining us. Just before you go, if you can please share the feedback. This will also be mentioned on the meetup page as well. You can take some time and then give some feedback. That will be really, really nice.
Yeah.
So we
Thank
keep
you.
connecting
Bye-bye.
with things, and then we also have some dojos. So we'll keep you all folks posted. Okay. Have a nice weekend, all of you. Stay out.
Bye.
Thanks. Thanks, Gaurav.
You.